Hello everyone, my name is Yibin. I'm glad to introduce my presentation. To begin with, I would like to acknowledge my supervisor Dr. Vasilis Friedrichs for his persistent guidance during the process of my project. From this page, I would like to introduce the outline of my presentation. We can see that this presentation is divided into three main parts, so let me illustrate these parts separately. In recent years, flying base stations have become more and more popular. Compared with the territorial base stations, flying base stations are able to be deployed more flexibly and use less expense, since drones can move to the areas like the earthquake-stricken areas, which territorial base stations cannot approach. However, since the altitude of drones may influence the signal, we should think about the suitable deployment method of drones. In this report, we divide end users into several clusters. In order to deal with the problem, we should firstly think about some clustering algorithms which may cluster end users. Secondly, the different layouts of end users are able to be considered because we should think of the reality. Finally, we determine suitable algorithms which are able to control the altitude, path loss, and receive the signal strength of each drone into a specific range. By referring to the relevant articles, we consider the three clustering algorithms. However, since the hierarchical clustering and the DBSAAN cannot determine the center of each cluster, we think of a minimum bounding circle algorithm, which can find the centers just as the figure shows. We also design a series of limitations. To begin with, we do not consider any mountain or basin, and the detection range is an ideal circle. In addition, the whole length of the site is 2 kilometers. Finally, we assume that the range of each drone's altitude is from 20 meters to 300 meters. If altitudes are over the range, we do not consider the corresponding clustering algorithm. In this page, there are some different layouts of end users. In the first layout, you can see that these end users are separated into 4 different groups clearly. In the second layout, there is a noisy point which may influence the result compared to the previous one. In the last layout, every location of end user is randomly generated. After our experiment, we acquire the results of every layout of end users. In the first layout, we can see that all of the data are in the limited range, and all of the clustering algorithms can be chosen. Turning to the second layout, we can see that one of the altitude of drones in K-means is over the range while the 2 algorithms are still hold their previous situations. Thus, we should choose the later 2. In the final layout, we can see that K-means cannot be chosen because one of the drone's altitude is over the range, while the data of hierarchical and DBSAAN are appropriate to cluster the layout of end users. Finally, I would like to make a conclusion. First of all, K-means can be used easily without any assistant algorithm compared with the other 2 algorithms. However, it is influenced easily by the noisy point and may not meet the best deployment of drones when the end users are randomly generated. On the contrary, hierarchical clustering and the DBSAAN are more stable when they are noisy point. However, apart from the previous disadvantage, some parameters of DBSAN, like the threshold of a neighbor's search radius and the minimum number of neighbors, should be adjusted during the experiment. That's all my presentation. Thanks for watching.